say, for the same reasons as at least people in England studied Latin and Greek and here Sanskrit, that it trained the mind, and then you'd be ready to do other things. But, in another remarkable coincidence, the transistor was invented in 1948 also. And that enabled us to realize many dreams, though it took quite a while. And I will talk about what were the fundamental contributions of Wiener and Shannon, and how most of them have really come true now, thanks to the integrated circuit. But since I don't want to go too much into mathematics, I want to emphasize the reverse direction. Among the contributions of mathematical engineering have been improvements in the way semiconductors are made. So while we use the semiconductors to implement theoretical ideas, in return we have done something for them as well. So I will describe that at the end. This is one of the famous pictures of Norbert Wiener, who is known. He was a remarkable mathematician, quite famous. But to the general public, he is known perhaps as the father of cybernetics. And now the word cyber is used as a preface to many, many things, as you know. So what was his 1942 report? He wanted to make a contribution to the war effort. And his first proposal was actually for a digital computer, but it was ignored. Then he came up with the idea of using his work in statistics to study the problem of anti-aircraft control. And here the problem is, you have in those days an enemy aircraft coming over the horizon. You track it for a while, and then you have to aim your gun, not of course where you saw it last, but where you think it's going to be in the time that it takes the missile to reach that point. So you have to try to guess or estimate where it is going to be in this time. Well, if there's only... The point is that aircraft can follow a number of different paths depending on the type of plane, depending on the pilots, and so on. So each time the trajectory will be somewhat different. And so he said we should really consider this as a statistical process. And what you see at any particular time is one realization of this. And let us try to set up a criterion for solving this problem, and saying there will always be an error. So how do you minimize the error? So he introduced or reintroduced a criterion that had been used by Gauss in astronomy called the mean square error criterion. You take the error, square it, and take the average, and find a solution that gives you the smallest value of the mean square error. This was a new concept in engineering, that you should introduce optimization criteria. Because most of the time people design circuits and systems by a trial and error, cut and try method. You think you can achieve this kind of performance at high frequencies. Try something. If it doesn't work, you twiddle something else and do it. Wiener said, well, let's set up some